To another Codewars challenge. This one is a level 7. We're doing it in Python and it's called Figure It Numbers 2 Pronic Number. As always, there will be a link to the challenge in the show notes right below the video if you want to try it out before watching my version of the solution. It's always best to learn by doing, so I'd highly recommend that. Also, if you like this stuff, please like and subscribe. That helps keep me going and helps keep you informed every time I post a new one of these videos. I try to knock out a few a week at least. So with that, let's get started. Okay, so a Pronic number is a number which is the product of two consecutive integers, that is n plus 1. Okay, so for example, 2 is a Pronic number because it's 1 times 2. 6 is a Pronic number. Okay, so this seems pretty straightforward. What I want to do is try a few things out, because I think what we can do is take looks like negative numbers are not Pronic numbers, which kind of makes sense. Two consecutive negative numbers. Okay, so I think I've got this figured out. Okay, let's see. 6 is a Pronic number. Let's start with an edge case here. So if n is less than 0, return less than or equal to 0. Let's return false. That gets rid of all the negatives and the zeros. Okay, so then after that, what we're doing is there's a long way to kind of check this, and that is basically just a for loop all the way up to a given number, right? So let's do 6, for example. Okay, so what we'll do is let's go, for I in range, and we'll go up to 6. So let's set n equal to 6 here. Okay, so we'll start at 1 and go up to n plus 1. Okay. Okay, so what we'll do is we're going to say if at any point I times I plus 1, right? So here we have first time through, we're going to have 1 times 2 in this case. If at any point it's equal to in itself, then we return true, right? So we have a Pronic number at that point. So I think we can do that here. I was going to bring it over here to show you, but there's not much to really visualize here. So what we'll do is we're going to go for I in range, and we're going to start at 1 and go up to the number. And again, this is computationally not the most elegant because you're for looping a bunch of excessive numbers that are not going to be. So I think at any point you get past the square root of the number, so anytime I go past the square root of it, I think you're at that point you're done. But we can try this out the long way first. So let's return if I times I plus 1 is equal to n, we return true. If we get at the end of this for loop and haven't had any trues, we return false. So let's test this out. It's looking pretty good. Okay, 0 is a Pronic number. Go figure. So let's just adjust that real quick. 0 is a Pronic number. False should equal true. I wonder. Okay, so 0 is a Pronic number. Go figure. All right, let's do this then. If n is 0, return true. So a couple of edge cases here that I'm throwing in. Not the most elegant way to probably write that. All right, all those tests are passing. So I think what I want to do is, before we do a submission here, let's see if we can shorten up that for loop. We don't have to go all the way up to n. And so what I'll do is let's, from math, import the square root. Okay, so what we'll do is we're going to go up to int of the square root sqrt of n, and we'll add 1 to that. I think this will still pass. All right, so that's looking good. Let's do an attempt here. Full submission. And basically all we did here was just shorten the for loop. So looks like we got it. Nice work.